me welcome you to the 28th lecture of surface mining technology NPTEL online certification course. In this lecture, we will start our new topic, that is transportation in surface mine. There will be 3 lectures on this. This is the first lecture, and we will consider the in-pit transportation system. What are the possible transportation systems available for surface mines? We will look into those in details. But as we do, let us look into the learning background required for surface mining technology course. Let us look into the learning objective of surface mining technology course and learning outcomes, expected learning outcomes from the participant of the surface mining technology course. And these are some of the textbooks and references can be followed in this course. And let us retrospect the previous lectures. So far, we have discussed the phases of mining a deposit. We have also seen the commencement of surface mining through the opening of box cut, and the different drilling procedures, drilling patterns required, and the machine operations are also discussed. Blasting technology and excavation by reaper, which is a blast free technology for excavation, are also discussed, and excavation of material, that is the excavated material by the reaper or the blast fragmented material, their excavation using the excavators are also discussed. The objective of these lectures on the transportation system in surface mines are to understand the possible transportation system in surface mines, to learn the operation of dumper transportation system, to understand the cost and performance calculation of our transportation system and shovel dumper combinations in the surface mines. Now, let us look what are the possible transportation systems in surface mine. For that, let us understand what we are carrying out in the surface mine. In surface mine, basically we are excavating 2 types of material, one is ore, another is waste or overburden rock. Now, this ore, these are useful material. So, we have to send this material from the mine, that means after the excavation, that this material has to be sent to some special cases, either to the crushing plant or to the stockpile or to railway siding, or maybe sometimes directly to the client, say like coal mines etc. Sometimes we can send the material using the truck from the mine itself to the power plant if it is situated nearby or so. So, these are some possible cases where the useful materials are being sent like this, or the waste and overburden rocks, those are either to be sent to the overburden dump, or we use those material to backfill the void area in the mine, or we can send those material if there is some alternate use, commercial use of this material. So, sometimes what is happening, say if the overburden rocks are comprising of sandstone, that material can be sent to the specially operated crushing plant, where that can be crushed to make the aggregate, or that can be crushed to make the sand. So, this type of alternate commercial uses are there, and if those are there, then the material has to be sent in that plant. Otherwise, that can be used for some other purposes, like the construction of the berm, construction of the haul road itself in the mine. So, these are some of the special use. In those cases, those materials are waste, but those are not shifted to that place, but those are utilized for construction of these things. So, these are basically the destination of the material. After it is excavated in the mine, this material has to be transferred to those places, and this is the way this can be carried out. Now, what are the means of transferring these things? we broadly classified in our surface mining system also we have discussed. This broad classification is either a discrete one or a continuous one. So, in discrete we are having dumper or trucks which are used for transporting the material. We are having scrapper also. This scrapper already we have seen one video in our ripper, where the scrapper is utilized to take the material excavated in the ground, lift that material, and simultaneously the material is transferred by the scrapper to the destination. Or sometimes we can use mine tub or railways, which are that can be, the tracks can be laid down in the benches of the mine, and those can be utilized for transferring the material. In fact, this was earlier a very common system before these dump trucks were popular. This was very common system in the mining transportation. We are having continuous transportation system, that is conveyor, slurry pipeline or aerial ropeways, but these are not so much common because these are required huge installations and other requirements. So, these are not very common as a mining transportation system, though it is technically possible, but there are some other constraints which are basically arresting their use, but these are transportation system carried out post plant use, but in mining these are not used. But in some cases in mining belt conveyor are found, conveyors are found as a transporting system in the mine itself. So, these are a broad classification of the transportation system in the mine, and let us before going to the discrete one, let us discuss about some conveyor system of transportation. This conveyor system is called shiftable belt conveyor system, where this belt conveyor system is allowed to shift from this particular place to the gradually towards as the face is moving. This is main belt conveyor system. This conveyor system is in general placed as the along the access road of the mine. So, as the dump trucks etcetera are moving through the access road, in the similar access way we provide this main belt conveyor. All the branch belt conveyors like this shiftable conveyors, they are moving along with the face, and they are discharging the material onto the main belt conveyor, and this main belt conveyor is taking the material from the mine to the outside pit. So, these are the some of the conveyor systems. This is called overburden bridge conveyor. In this overburden bridge conveyor, as the material is removed at this position, this material is directly taking and taking in this overburden bridge, and this long bridge conveyor is taking this material, and these are supported like this, and this material is transferred to the overburden dump. So, this is the way this material is working. You can see this is one long discharge boom, this is a long receiving boom, and this is one supported at this position, another supporting at this position. By this way this machine is being operating. So, it is a long bridge conveyor, and this system is very fast and effective for transferring the material, overburden material, where the direct casting for the backfilling is practiced. So, this is very useful technique and fast technique. However, this essentially required a higher capital investment, and this is high angle conveyor, where the material is transferred with a angle higher than the 18 degree. Up to 18 degree the conveyor is the normal conveyor which are practiced, and above 18 degree high angle conveyors are used. Sometimes it is sandwich belt conveyor, sometimes it is different other types of conveyors are also available. So, this is the high angle conveyor system, and this is the mobile transport conveyor system. This is a mobile equipment, and a number of mobile transfer conveyor systems are available. So, if one machine is operating, and as the machine is moving, between that machine operating phase and to the main belt conveyor phase, we are having some flexible conveying system. So, this mobile transfer conveying systems are very flexible. These are having high mobility, flexible, high mobility, and these are having one side, it is the receiving end, and this is the transfer end. So, in one boom it is receiving the material direct from either from another mobile transfer conveyor, that is MTC, and it is discharging either onto a MTC or to a main conveyor. It is either receiving from a bucket wheel excavator or similar type of excavating machines or from the in-pit crusher and transferring that to the main conveyor or MTC, something like that. So, it is acting as the intermittent transferring system. So, that can be utilized here, and this is very popular and giving high productivity in the transportation system in the mine. And high angle conveyor is very good system to negotiate the inclination, high inclination for the in case of deep mine. In case of deep mines, high angle conveyors are very popular and useful techniques of transferring the material. Now, let us discuss about the discrete system. In discrete system, we have already discussed scraper. You can see scraper having a scraping blade at this position. This is a scraper blade. This scraper blade, as the scraper is moving in this direction, the scraper blade is basically taking the material, loose fragmented material from the ground, and this bucket of the scraper or pan of the scraper is filled with that material, and once it is filled, then the scraper take that material and discharge into the discharging point, that is either a crusher or the dump yard where the scraper is dumping the material. This is the railway tub transportation system. This was very common earlier. This is the small tubs, different types of tubs are shown here. These small tubs were utilized for transferring the material, and nowadays this method is popular in the underground mines, but in surface mine these are basically replaced in surface mines, these are replaced with the dump truck transportation system. So, now let us look into some of our dump truck transportation system. In dump truck transportation system, we are having different types of dumpers. This is some of the dumpers discharge arrangements. So, dumpers are basically the trucks which are featured with automatic discharge system. So, these are basically automatically discharged. This is side discharge dumper. These are bottom discharge dumper. And this is rear discharge dumper. Now, if you compare into this discrete system and continuous system of transportation, the discrete system is carrying a smaller unit having the limited capacity, but this is highly productive. Energy efficiency is extremely poor for the discrete system, especially for the dumper transportation system, but it is having better energy utilization. If you look into this, you will find out, say suppose the dumper is having say capacity of 4050 ton. So, the dumper carrying capacity is 4050 ton and its tear weight is say 300 ton. So, that means, when the loaded dumper is moving, that time energy required for propelling the dumper is for 750 ton, whereas the dumper is returning back empty, that time the energy required for the propelling is 300 ton. So, that means, together for shifting say 450 ton material, the energy required for shifting is say 1050 ton if you are considering ton kilometer. So, this is the ton kilometer energy is required for this. So, that is why the transportation system is, this transportation system is not very energy efficient system, but these are having facility, the capital requirement is less. The installation requirement for this continuous system like conveyor etcetera, the capital requirement is high, but running cost for discrete system is high, most of the time it is diesel powered etcetera. So, that is a costly system, here it is electrical system. So, running cost is less, but this is also having some flexibility, mobility is very great, your shovel can change the position, the dumper can negotiate the changing in the position from one face to another face, one bench to another face, one dumping point to another dumping point, stockpile to the railway siding, all these changes can be immediately negotiable in this case, but here it is not possible. It is the mobility is very difficult. That is why we are discussing about the mobile transfer conveyor. All those intermediate systems are required to negotiate with this mobility only, and this is adaptable for varying capacity. That means, suppose today our production requirement is less, say 1000 ton per hour is the today's production requirement, and we are deploying say 7 dumpers for that. Tomorrow if the requirement is for 200 ton, we will deploy 2 dumper, we will not deploy 7 dumper in that case. So, that can be easily negotiable in this case, but in this case that cannot be possible. The conveyor which is 1 meter wide and running at a speed of 2 meter, we have to run that in the same speed, though the quantity requirement is reduced from 1000 to 200, but we have to run the installation with the same capacity. So, that is the problem with this system and we cannot have any control here. This is having high environmental degradation, mostly diesel operated. On the movement of the dumper on a haul road, it is generating dust, sometimes often it is buzzing the horn, that is also creating noise pollutions, and this is also problem with the safety and monitoring is difficult, as the dumpers are moving, it is not a rigid system, moving flexibly, or driver skill is essentially required, and then most of the surface mining accidents are pertaining to the haul road accidents only. So, that is why this is a very difficult one for controlling these things, and we need high manpower requirements. Automations are difficult, though nowadays good research work is carrying out on the automations of the dumper transportation system, but these are the facilities with the continuous system, especially for the environmental degradation, safety and manpower requirement and automations. These are greatly available in the continuous system, and the main is that continuous system is highly productive and that is why very efficient. But when we are looking at the applicability, the discrete system is applicable for very big sized boulders, non-uniform rocks, that means that fragmentation distribution, if it is poor also, then also that can be negotiated with this dump truck transportation system. Any types of feeding can be used, it can be fed with the shovel, it can be fed with the front end loaders, all those feeding system, it can be fed with the conveyors also. So, whatever the means that is negotiable to those, and the feeding and discharging points, loading or discharging points are not fixed in this case, it is very flexible. So, this is very flexible and you can immediately change. The moment one dumper is addressing the shovel number 1, if it is instructed next time it has to address the shovel number 2, it can go for that immediately, but that much flexibility is not available with the continuous excavation system. So, applicability is different in continuous excavation system. These are applicable to the small and uniform distributed size of fragments only. Large boulders cannot be taken in the conveyor system, and if the boulders size distribution is very scattered one, then also it cannot be taken in the conveyor system, because that will spill out from the conveyor. And feeding system should be a steady feeding system. You cannot directly dump one bucket load onto the conveyor, that is not possible. So, the bucket has to be discharged on a feeding system, that may be a apron feeder, that may be a belt feeder, whatever feeding system is there. The material has to be taken in the conveyor through the feeding system only, and the feeding and loading discharge point are also fixed. That means, the conveyor system has to take material from one point and it has to discharge the material at a particular point. So, this type of flexibility is not available with the continuous system, those which are available in the discrete system, but discrete system it is not energy efficient, it is costly, but these systems are not that much costly and it is energy efficient also. So, these are the basic advantages and disadvantages and applicability of the discrete and continuous systems of excavation. Now, let us look into some of the continuous system, video of some of the continuous system. Discrete system we will discuss. This is one arrangement where the blast fragmented rocks are crushed first. So, to make it a uniform size and smaller size, so that that can be conveyed after that. So, this is a negotiation between the discrete and continuous system. A small portion where the discrete transportation system is used, but the major portion where the continuous transportation system is used for the adjusting the cost. So, this is the way this is carried out, where the first after the blasting the material is taken and then the material is taken into the crusher, it is reduced in the size and then that size is then conveyed. So, this is the in-pit crushing and conveying system, which is used for the transferring of the material. This is the discharging system of the conveyor, where the spreader is used for constructing the dumps. So, after a particular dump formation, the conveyor can be shifted once in a while. So, this is the shiftable conveyor. Now, the second row of dump can be made. Then again the bench floor is extended. This video is available in this YouTube link, and by this way the uniform dump can be formed using this spreader system. So, overburden rocks are blasted, then it is taken in the in-pit crusher, then the in-pit crusher make the fragment size uniform, then that is taken in the conveyor, then finally discharged with the spreader. So, this is in-pit crusher conveying system. This is a shiftable belt conveyor system, where the material is taken from the bucket wheel and material is discharged using a mobile transfer conveyor. The material is discharged to a shiftable conveyor. Now, behind this the shiftable conveyor is working. and this is a bridge conveyor. This is a bridge conveyor where the material is discharged through this bridge conveyor and which is forming the overburden dump or backfilled in the back side of the mine. So, material is excavated in this site using a bucket chain excavator. This bucket chain excavator can be seen here. Then the material is transferred through this bridge conveyor and being discharged at this position. So, this is intermittent discharging system, so that the bench can be extended in this side also. So, this type of transporting system gives us the facility to go for the highly productive mines, and with the highly productive mines we can go for deep surface mining. In fact, using this continuous excavation system only, some of the German coal mines are operating at 500 meter depth also in surface mining system. So, this is more or less end of this lecture. Thank you.